Okay, so for today, I need to teach you, big picture, a bunch of little properties of logs and about graphing logs. All right, I'm going to start with the properties of logs. And those are some things like this. If you had a problem that was kind of a weird mix of an exponential and a log, because see, it's got a base and the exponent is a log. This one's always weird for kids. And I'll show you, it involves some pretty heavy algebra. I'm going to try to show you why the answer to that is 8. Now, if you just want to like get the short and quick and dirty, it's because the bases are the same, the answer is 8. But if you want to know why it's 8, try to be that kid that wants to know why it works. All right? So I'm going to rewrite this as a log. And you might be saying, it was a log in the first place. No. It was an exponential because the log was in the exponent spot. So if I rewrite it as a log, I got to know what base to use. Well, that's a no-brainer. The only base I ever used in both parts was a 5. So this has got to be log base 5. And then you go over here. Remember how you always have to go to the other side? And then that's an x. And then you have to go back over here, but that exponent is log base 5 of 8. Now look, do you see there's log base 5 on both sides? So what's x got to equal? 8. That's why x is 8. Ishi, I can tell you had issue. Tell me what's going on. What bothers you about that? All of it. I'm going to give you one more like it. 8 to the log base 8 of 7. Now, first principle here is you can, if you want to, say that all equals x. Because there's no variable. Now we put in a variable. And it just gives me stuff on both sides. Now I can do a rewrite. This one is right now not a log. It's an exponential. It's like that's the exponent. So since it's an exponential, I can write it as a log. So I just start by saying log. Then I got to figure out what the base is. Well, it's got to be base 8. But then you're using this as your base. So then you jump to the other side, and the next thing you write is an x. And then you jump back, and it all equals log base 8 of 7. This part comes to the end here. And then once we have that, I hope you can see that they both have the same exact log 8, and therefore their arguments must be the same. X must be 7, so x equals 7. Now, you don't have to write that every time to get this answer. In fact, we expect you to just see this and go, oh, bases are the same, the answer's already there. It's a 7, done. All right, here's another pattern that you got to be able to recognize. I can look at this, and I can go, well, the answer's 5. But how did I do that? Because I, in my head, replaced the 32 with a 2 to the 5th. Why is that smart? Because the bases are the same. And the answer is, I like to say the answer is already there. Because I don't want to say that the answer is always the exponent. On this kind of problem, it is the exponent. But on the other kind of problem, it wasn't an exponent, it was actually the argument. But the answer was there. So if the bases are the same, the answer is already there. Does this remind you at all of this kind of question where it was like 2 to the x is equal to 32? And then you had to replace the 32 with the 2 to the 5th? It's the same thing. It's the exact same thing. You know why? Watch, I'm going to go back in time here. When I had this, couldn't I have said equals x? Then couldn't I have rewritten it as 2 to the x equals 32? And then couldn't I have changed the 32 into a 2 to the 5th? And then they have the same base, and then the x equals 5? That's exactly what you just did on your last test. It just involved a rewrite first. And my proposal was that you just get used to saying, oh, I'm going to replace the 32 without all of that other song and dance. I'm just going to replace the 32 as a 2 to the 5th. And then if these two are the same, the answer is 5. Okay, let's see if you really caught that. Log base 3 of 27. Say the answer if you know it. 3. Now prove it by replacing the 27 with something. What do you think I want you to replace it with? 3 to the third. And now, these are the same, so the answer's there. And it's 3. All right, here's a little more advanced one. Log base 3 of 1/3. This one annoys people because it's harder to make 1/3 into 3 to the something. But if you know the right answer, it becomes obvious. You're like, oh, that's not that hard. This 1/3 could be replaced with a 3 to the what? -1. Oh, your class is better at negative exponents. Nice. So then the answer is just -1. All right. This could absolutely be a question on an ACT test. It's actually be a pretty easy one, so this would have been early in the ACT. They're going to put it in late in the ACT. They might have done something more like this. Log base 8 of 2x equals log base 8 of x plus 4. And then, if it's a little harder one, but it's still not that hard. Who can tell me what little equation I have to solve? Raise your hand if you think you know. RS.
Wouldn't it just be 2x equals x plus 4?
Yep. And you get, we just subtract x and then divide by something and no big deal. I'll do it. Minus x, x equals, oh, then I have to divide by something. It's just x equals 4. Done. So how did that work? Well, once you have the same base, log, then this has to equal this. It's kind of like having the same bases, then the powers had to be equal. It's kind of like that. All right. So then here's a little more advanced one. This will be getting a little further, maybe up into the 40s on the ACT, like problem 40. There's 60 questions. Let's say it said log base 2 of x plus log base 2 of 7 is equal to log base 2 of 30. Nope, sorry. 35. If you can figure this one out, I'll be impressed. Got it. First of all, don't just say the answer. Tell me what you think I should do to solve it.
You multiply the 7 and the x.
All right. So, tell me what you're talking about. A 7x.
The exponents of the log 2's on the left side are 7 and x you multiply.
Those are called arguments, but yes, the 7 and the x. Okay, those arguments, you're going to multiply them?
And then you said it equal to 35 because that's the argument on the other side.
All right, you're really close. You just are missing a little bit of showing work part. So I can tell you've got it, but you're just kind of being vague about how all that turns into 7x, because it doesn't actually turn into 7x, but it turns into something close to that. Yes?
Would it be x plus 7?
Nope. All right. Good guesses. And you actually were right. You're just not telling me the right why. Why there's a 7x involved. All right, so I'm going to show you why there's a 7x. There's a property of logs that says if you add two logs that have the same base, notice they both have a base of 2, then you can put them into one log, base 2, of 7x. That's the reason I was objecting, is because you were leaving off the log part. Log base 2 of 7x, that is a property. If you have two logs that are added, then you can combine them into one log where their arguments are multiplied. Log base 2 of 35. Okay. Now, those two are the same, so these two are the same. Can you tell x has to be 5? Once you get that part done, it's so easy. It's just the answer is just solve that little equation. All right, here's a little tiny bit. Well, how about this? I just won't help at all. See if you can do this one. log base 3 of x squared plus log base 3 of 3 is equal to log base 3 of 27. Hint? No, no hints. Let's be quiet, server. Okay. Pausing. All right, so if we put in 0, we would get the asymptote. If we put in 2, right here, we would get log base 2 of 2, which is 1. What's another good call for numbers to stick in for x? 4. Because log base 2 of 4 is easy to do in your head. Because log base 2 of 4, you replace the 4 with a 2 squared. And all of a sudden, that was easy. The answer was 2. Let's do one more. About log base 2 of... I'm going to stretch you a little bit. I think there's a lot of kids that can do this. 1/2. Put a 1/2 right here. Figure out the answer in your head. There's a 1/2 right there. Isn't that the same as 2 to the negative 1? So the power is the answer then, right? So who had negative 1 down before I said it? Nice work. Okay, you could have done also 16 because, or even one easier than that, I suppose, 8. Let me do that first. You get out 8. I put an 8 here. It's really like 2 to the 3rd. And so then if that's 2 to the 3rd, then the base is the same. The answer is 3. 8 goes with 3. There's a million points. How many do you need on the test? 4 minimum. 5's better, but I'd take 4. Sometimes the last point's really hard to get, so 4 points is fine. All right. One more thing on that graphing deal. This one is a log that has been reflected high-vo. Remember the vertical on the outside? That's a vertical reflect. This is a left 7, and that is a down 5. I'm going to do this in the speed version. You know this is what a log looks like. Tree blowing over the wind. Then I need to negative out in front is a vertical reflect. A lot of people are not good at this, but basically it looks like that. Next, I got to move it all left 7 and down 5. Okay, pausing for a second. All right, so if we put in 0, we would get the asymptote. If we put in 2, right here, we would get log base 2 of 2, which is 1. What's another good call for numbers to stick in for x? 4, because log base 2 of 4 is easy to do in your head. Because log base 2 of 4, you replace the 4 with a 2 squared. And all of a sudden, that was easy. The answer was 2. Let's do one more. About log base 2 of... I'm going to stretch you a little bit. I think there's a lot of kids that can do this. 1/2. Put a 1/2 right here. Figure out the answer in your head. There's a 1/2 right there. Isn't that the same as 2 to the negative 1? So the power is the answer then, right? So who had negative 1 down before I said it? Nice work. Okay, you could have done also 16 because, or even one easier than that, I suppose, 8. Let me do that first. You get out 8. I put an 8 here. It's really like 2 to the 3rd. And so then if that's 2 to the 3rd, then the base is the same. The answer is 3. 8 goes with 3. There's 1,000,000 points. How many do you need on the test? 4 minimum. 5's better, but I'd take 4. Sometimes the last point's really hard to get, so 4 points is fine. All right. One more thing on that graphing deal. This one is a log that has been reflected high vo. Remember the vertical on the outside? That's a vertical reflect. This is a left 7, and that is a down 5. I'm going to do this in the speed version. You know this is what a log looks like. Tree blowing over the wind. Then I need to negative out in front is a vertical reflect. A lot of people are not good at this, but basically it looks like that. Next, I got to move it all left 7 and down 5. Okay, pausing for a second. Well, from here, I would just remind you that you use an XY chart. And the XY chart will give you a bunch of points. You graph those points. And you should know that it, generally speaking, the points should be down in here because it's moved to the left 7 and down 5. So you make an XY chart, find some points like I'd put in -6. And that one's going to work out pretty nice for you. -6 goes in and I get log base 2 of 1. And then if you won the argument, you got a 1 in the argument spot, that it's equal to 0. Plus 5 is 5. All right, that's all I have for you for today. We're out of time.